Thank you very much. My name is Xinchi. I'm currently a PhD student at University of Cambridge, and it's my pleasure to present to you our open source project, Flower, the Federated Learning Framework to Open UK today. Flower is currently collaborating outcome with a lot of engineers and a lot of research across the world, and it's be using by a lot of research and the communities to run experiments with federated learning currently. So I think I will begin by talking about exactly the motivation of using federated learning and why I'm so passionate about federated learning and what is exactly federated learning. Traditional machine learning methods relies on a data center, which is what we usually call centralized learning. It requires the data to be uploaded to the data center and perform the training over there, which largely restrict and preventing us from inventing new technologies and applications and doing many things that the society are just desperately required. When people talk about federated learning, one of the reasons that pop to the head is the user privacy, the data privacy, and the data control. And that is one of the key reasons, but that is not the only one. So apart from the user privacy and the data securities, there are also numerous papers and the literatures emphasizing the energy consumptions of running huge models on the huge data centers and the carbon footprint of training this kind of models over and over again. Imagine if we have a model and you need to upload all the data samples to the data sample and then to train the model from scratch. And it has to be done so many times for different data centers because the data is not allowed to share. And we also published our research paper, first look into the carbon footprint of federated learning, which compares the carbon footprint of training a machine learning model in the data center, centralized way, and in the federated learning way over the edge. Also, there's a lot of discussion about the fairness of the model and its ability to generalize across different demographic and geographic constraints. The fact that the data center paradigm relies on a static, heavily curated data that does not change over time because it has to be collected, and it's very complex and it's very expensive to collect, and it's trapped in the scenarios that you can only use this static data set, and it's never going to be generalized across the world and over time. So with this problems, we think the federated learning is the way to move forward and transforming the way of the machine learning work and can be conducted to address all these problems. So exactly what is federated learning? Federated learning is proposed by Google in 2016. Opposed to centralized learning, federated learning do not require the data to transmit to the data center. The data can stay on the device, which means that the machine learning model can have access to larger amount of the data, more generalized data, without worry about the privacy issue for collecting the data. It trains the model following communications round. So there's a central server to coordinate the training. During each round, the central server will select a number of clients or organizations to participate in the training and broadcast the current model parameters to these clients. After receiving the current model parameters, these clients will then train the model using the local data set for a few epochs, which is the hyperparameters you can tune, and then upload and update the model parameters to the central server. The central server will then aggregate these model parameters and then to start the next round. So in this way, the model parameters are only the model parameters are exchanged and not the actual data set. Nowadays, federated learning is already implementing in some simple tasks such as the Google keyboard, but not for more complicated scenarios such as collaborate to learn medical models for the cancer detections across different hospitals or across different research institutes, these kind of scenarios. So we believe with more advanced and developed tools like Flower, we can soon to achieve this in the near future. And so we introduce our open source federated learning framework, Flower. When talking about federated learning, there are usually two types of setup, the cross-silo or the cross-device. In the cross-silo setups, they are usually talking about the clients are more like organizations or institutes or banks or hospitals, which has a larger number of the data sets and more advanced hardware to train, and the data samples, the distribution might be more similar. And another way is the cross-device, which more like the mobile phones and the IoT devices, which the size of the data sample can be really limited and more secured. For example, if you think about the data you collect from the cars, the road condition can be very different from different locations, and hence the distribution of the data set will be very different. So the Flower is designed to support any kind of the FL setup, whether it's across the organizations in the cross-silo scenarios, or cross the device over different phones to train to be able to support in different apps or different kind of the devices like mobile phone, like cars. So what we really want is to train the model like any kind of the device, like in the cross-silo scenarios or cross-device, or the cars, or combining of the cars, of the phones, or the IoT device, or any kind of the home robots. So basically, it can be achieved and can be trained on any kind of the device. And also, on the server side, we want the Flower on the federated learning to be able to run on different workload, whether it's the vanilla federated learning or federated analytics, or more innovative way of the combinations or the hybrid version of different kind of workload. Also, we want to highlight that Flower is not only for the corporates or the organizations or the institute, it's also for the academic research as well, which you don't have access to multiple devices, and then you want to run your experiment to test all your theories on the simulation scenarios. So we built our virtual client engine to run the simulations, which enable us to scale up to a large number of the clients within a single machine. So in addition to what we saw, we actually want to do is at different levels. So first, we want people to able to build and run experiment systems involving minimal number of the clients and make it easy to prototype new ideas or theories on your machine. And then we want you to be able to scale up of this experiment on the cluster of machines. And then pure simulations does not really cut it, especially if you are interested in real-world scenarios with the heterogeneous hardware environment. So we want you to be able to run on real devices or real clusters, as well as eventually, if you are happy with what you have, we want you to be able to deploy it into the productions and to global distribute it across a large number of the clients. So you probably guessed it, there's a lot of technical challenges, and that's why Flower is working hard with a lot of researchers and engineers across the world. It's a collaborated effort. And Flower is also able to support different kinds of platforms, different kinds of libraries, different kinds of languages, either simulations or real devices, or over the cloud. We also have specific libraries such as the speech brain to be able to run the speech recognitions over Flower. We currently crossed 1.9K stars on GitHub, and the most amazing part is not just the numbers, it's the fact that Flower is a global community with the FL enthusiasts. It's not just like being able to do the research, and then it's delivering Flower's mission to make the federated learning more approachable and easier to run and more easily accessible to everyone. Now we have released Flower 1.2, and at the same time it feels like it's only a starting, so we're planning a lot of stuff going forward, and today I would like to give you a first glimpse of the stuff and the project we are working on and tackling right now. Even though with federated learning, the data set stays on the device, it's still not guaranteed for the privacy or the security of the data set. It is shown in many existing literatures that even with federated learning, it's vulnerable to various attacks like the membership attack, membership inference attack, data reconstruction attack, backdoor attack, or data poisoning attack, model poisoning attack. So with this kind of vulnerabilities, a lot of methods are developed or techniques such as the secure aggregations. So Flower is working on modular agnostic infrastructure to do this privacy-preserving machine learning workload. Currently, it's already on a plain secure aggregation is already implemented, but we would like to make it have more usabilities and modularities, which means that in the future it's easier to use secure aggregations, and we want it to be forward compatible with new and emerging approaches and techniques. Also, we would like to make Flower to be able to run multiple models, multiple tasks workload for more comprehensive machine learning tasks. Today, this workload are possible, but it's non-trivial to build. So we would like to build Flower to make it run independently, more smoothly, and easier for the researchers. Another point is currently Flower is running FL synchronously, which means that it runs on communications round. The central server will only aggregate the model parameters after you receiving all the updated model from the clients. But this means that it will suffer a lot on the stackers effect, meaning that if one particular client have very poor hardware, it trains really slowly, or if the internet is just really bad for the uploading the model parameters, which means that it can stuck at a particular round forever. So we would like to make it possible for the Flower to run asynchronously. How to run asynchronously feather learning efficiently without compromising the performance is still an ongoing research area, but we would like to build our Flower to be able to run and do this experiment very easily. Lastly, through this lens, it's very obvious that Flower is it's kind of like the foundation. It's a group effort. It's a very early stage, but we are excited about it, and we wanted to share with all of you. So if you are excited about Flower's roadmap or about feather learning, please feel free to contact us, to collaborate with us, or contribute in our code or run the experiment using Flower to test it out. Thank you very much for listening. Here is my email address, and here is the screenshot of our paper if you want more details about the Flower and the framework. And also, you can check out our website for more documentations or informations on the new projects. And I'm going to open up for questions. Thank you very much.
We get the microphone? Oh, there's one there.
Just turn it on. I'm all across there.
We are working on a similar, let's say, technology. How you solve the problem of standardization of different sources of data? I suppose you are using semantic. This is the first question.
I'm sorry, I don't.
I mean, the standardization problem of data, because we have several types of data.
Yeah.
So this means you have to standardize them.
Yeah.
To do this one, especially in an area of federated training, etc., are you using some kind, you mentioned you use virtualization. This means a semantic approach or other type of...
I think how you process the data is another problem of how to run FL efficiently. It's not to do with the framework. So it's like it opens up another question, how to deal with different kinds of data sets and how you build new strategies for FL to run, to have perform better, but it's not exactly. So our framework is very open and it's very agnostic to have for you to implement new ideas, to allows you to pre-process the data very easily. Everything is modular, so whenever you want to do to standardize your data or whatever you want to do to pre-process your data, you can easily achieve using Flower.
So I see that you are dealing globally. This means you can access from any part of the world on...
So this is you mean globally we want to do is the kind of the roadmap, like currently there's a lot of people from globally are using that, but eventually if you want to put your stuff into production for the globally, but the Flower as a framework allows you to do it, but how you actually do it is kind of another question regarding the regulations, the laws, and how you standardized that. That's not, I feel like it's not directly to do with the framework itself.
Oh, I see. Okay, thank you.
Thank you.
Any other questions? No? Okay, well,
Thank you very much.
so much. That was a great talk.